Hi there. Welcome to section 3.5, arithmetic sequences as linear functions. What this means in regular terms is that I'm going to give you a sequence of numbers, like a pattern. You're going to figure out that pattern, and then you're going to be able to write a linear equation that matches that pattern. So first of all, let's talk about a sequence. A sequence is a set of numbers. It's in a specific order. You can't switch it up. You have to just take what I give you for that series of numbers. If the difference between the terms between every one is constant, it's an arithmetic sequence. Or instead of saying the word constant, we could say stays the same. Or basically, you're looking for a pattern. Adding or subtracting is your pattern. And that pattern number is called the common difference. It's the constant rate of either increase or decrease. So if it's increase or decrease, that means that you are either looking, are you adding to get from one number to the next, or are you subtracting to get from one number to the next? One of those two options. If it's a multiplying, if it's a dividing, it's a different kind of sequence. It's called a geometric sequence. So it's got to be either adding or subtracting. That's always what you're looking for. So let's skip this first example. Let's just go to some plain old examples 2 and 3. So example 2, the directions say determine whether each sequence is an arithmetic sequence and explain. It's a yes or no question. So what we're going to look for is there a pattern? To get from -4 to -2, -2 to 0, 0 to 2, is there a pattern to get from one to the next? -4 to -2, hopefully you see that this is adding 2 every time. So yes, this is an arithmetic sequence. How about B? B is a little calculator work. You might need to grab your calculator to get from 1/2 to 5/8. From 5/8 to 3/4, from 3/4 to 13/16. So what I would do is I would take the second number and subtract the first. So 5/8 minus 1/2, see what you get? I would take the 3/4 minus the 5/8, so one right before it. I would take the 13/16 and subtract the 3/4. I think when you do that, you get a difference of 1/8 every time. It's going up. The numbers are getting larger, even though they're fractions and less than 1. So yes, this is an arithmetic sequence. If we didn't have a common difference, if we didn't have the same pattern, it would be a no. So example 3, we're going to skip C. We'll do that one in class, both of these C's. Find the next 3 terms of the arithmetic sequence. For A, we already found out that it was an arithmetic sequence. We found out that the D value, or the common difference, we call the common difference D, is adding 2. So what will my next 3 terms be? Seems pretty simple, right? Add 2 and you get a 4, add 2, you get a 6, add 2 and you get an 8. In that one, we already found the common difference. In B, we didn't find the common difference yet. So to get from 9.5 to 11.0, get from 11.0 to 12.5, what is our common difference? How are we getting from one term to the next? Another adding one. I should have gotten some subtracting ones. It looks like we're going up 1.5 or 1.5 every time. Again, if I didn't know, I'd go to my calculator. I take the 11.0 minus 9.5. I take the 12.5, subtract 11.0. So always the second term minus the one before it. Which means my next 3 terms, if the last term I give you is 14.0, if I'm following the same pattern, the next one should be 15.5. The one after that should be 17.0 or 17. The one after that should be an 18.5. Double check, make sure I did my math right. Let's skip C. We'll come back to C. We'll probably do that one in class. So now that we see that, that seems really simple, right? We've got ourselves a big equation or formula. The nth term of an arithmetic sequence with a first term of a sub 1. Notice I said that a sub 1, the little tiny one there. And a common difference D is given by this equation. This is important. Make sure you get this down. A sub n, we could also substitute that with a y if we wanted to. but we can figure out a specific term, like if I said, find the 7th term of this sequence. Well, we could add our way all the way up or subtract our way up to the 7th term, or we could use a formula. But I'm also going to, if you look below in example 4, ask you to write an equation for that sequence, the nth term. So we'll say a sub n equals a sub 1. I'm going to highlight this guy because all you do is substitute in the first term in that sequence. So a number's going in that spot. Over here we've got plus n minus 1 in parentheses times d. Notice this will be a distributive property problem. Probably, maybe when we write it, we'll put the d first so you remember. But the d is actually going to have a number substituted. Remember, d is the common difference. That's the pattern number. And then when we get a little bit further into the next couple examples, we can actually put a number in for n. N says if we want to find the 7th term in that series, we would put a 7 in for the n. If we wanted to find the 58th term in that series, we would put a 58 in for that n. But let's get the equation first. So example 4, it says to write an equation for the nth term of the sequence, negative 49, negative 35, negative 21, negative 7, dot, dot, dot. Notice it keeps on going. That dot, dot, dot tells us. So the first thing we should do is find the pattern. How do you get from negative 49 to negative 35 to negative 21 to negative 7? Again, if I went to my calculator, I'd take the negative 35 minus a negative 49. The calculator will choom choom. I think you're going up by 14 every time, which means that our d equals 14. What's the first term in this series? Well, the first term that I give you is a negative 49. So we have everything we need. Those two highlighted things right there, I just wrote those down. So let's write ourselves an equation. We're going to keep that a sub n, even though it looks weird. So it's a large A with a littler n down below, equals a sub 1. You told me the first term was negative 49, plus parentheses. N minus 1 stays exactly the same inside those parentheses. We're not going to change that. And d, my common difference, we said was add 14 or a positive 14. Notice if it were a subtracting 14, we'd put a negative, but this is a distributive. We have to finish this problem by getting rid of that. So we're either going to distribute a positive 14 or a negative 14, but it's a multiply. It's not adding or subtracting at the end. So that means I've got a sub n, negative 49 plus 14n minus 14. Do you like my distributing? And then I see a pair of like terms. They're on the same side of the equal sign, so I just do the math. Negative 49 minus 14 is a negative 63, I think. I'm just going to bring down that 14n. And here's my final answer. When I ask you in the practice problem to do exactly this, this is a good guide to go back to. So my final equation, even though it looks strange, a sub n equals 14n minus 63. All right, so now keep that in mind. Keep that formula in mind. Let's do this example 5. First thing at the top, I'm going to write the equation. A sub n equals a sub 1 plus, is anybody going to object if I put the d first and then put the n minus 1? I think I like that way better because now you really see distributive property, right? Let's write it out that way. So it says to write an equation for the nth term in the sequence 0, negative 4, negative 8, negative 12. So the first thing I'm going to ask you is what is the a sub 1? What's the, actually let me write it this way. What's the first term in that sequence? Looks like a 0 to me. What is the common difference? How do we get from 0 to negative 4, negative 4 to negative 8, negative 8 to negative 12? Looks to me like we're subtracting 4 every time. At this point, we know our a sub 1, we know our d. We're going to fill those two things in, and we're going to do our distributive property. So a sub n, we're answering example A here, 5a. So a sub n equals, first term was 0, plus common difference, negative 4. Keep the n minus 1 exactly as it is. Let's distribute. So a sub n, negative 4n, everybody agree with a plus 4 there? And I have a 0, I don't necessarily need to write it, but if I write it, I'm just going to look and say that my final answer, even if I combine these like terms, which seems a little strange, would be negative 4n plus 4. Negative 4n plus 4. So ignore that graph paper on the side for a second. So what this means now is that I can do example 5b. Find the ninth term in the sequence. So 9 is going to become the n. I can do myself a math problem. So this is A. I can do myself a math problem, and I can put a 9 in for that n and find myself an answer. So for B, I'm going to take that same equation, a sub 9, because that's what I want to find, equals negative 4 times 9 plus 4. So this is what I put in there from part B, the ninth term in the sequence. So that ninth term would be negative 4 times 9 is negative 36. Negative 36 plus 4 would be negative 32. So I have to write the equation, and then I can put an n value in there and find the actual answer. Now it says to graph the first 5 terms in the sequence. Well, that's easy, right? Think of this like my first term is 0. Oh, I gotta find some. My first term is 0. My second term is negative 4. My third term, I'm just adding this x column right here, but notice the y is staying with my original sequence. My third term's negative 8. My fourth term is negative 12. My fifth term would be, that's going to fall right off the graph, but so I can graph that. So over 1 up 0. Over 2 down 4. Over 3 down 8. Over 4 down 12. I'm now falling off the graph. But there's my first 4 anyway, terms of the sequence. So this is the sequence. This is just x values are just putting some numbers in there. Last but not least, what term of the sequence is negative 68? Well, this is where we're going to go back to our original equation. Notice how in B we put a 9 in for the n. In D we want to find n. But we know that the answer is negative 68. By the way, the graphing, they'll ask you to graph in the problems, so that's the only reason I wanted to mention that. It's really not that big of a deal. Don't worry too much about the graphing. Let's worry about the equation. So we know the answer is negative 68. So here's the equation we wrote for letter A. Negative 4n plus 4. We know the answer is negative 68. We want to find n. What term, the nth term, is what we want to find. So now we've got ourselves an equation to solve. You know how to solve these. We just did these. We've been doing them all along. So negative 68 minus 4 is a negative 72. Finish solving this by dividing by negative 4. And I should get n equals, what does that come out to? A positive 1/8. That was for letter D. There's a lot of stuff happening here. Most of this is following along and seeing that equation and then using that equation to help you out. So let's skip example 6 and 7. We're going to do these in class. Here's the two things that I want to make sure you know. What's the formula or the equation to write an equation of an arithmetic sequence? Jot that down. Feel free to put the D on the other side so it looks better for distributive property. And here's your practice problem. I'm giving you the sequence 7.2, 4.3, 1.4, dot, dot, dot. First question I want to know, what's the common difference? Second thing, what's the first term or the a sub 1? So this will be D. This will be a sub 1. And then the third thing I'd like you to do is to actually use that equation and write it. Don't forget to distribute. So look back at that one example we did right underneath the formula. Example 4 might be a good spot to do that. Find the common difference, find the first term, and then plug those in. Remember, the n will stay an n, so you're going to have an n in your equation. That'll be your variable. That's it for section 3.5. We'll see you next time.